Hi, my name is Eric, and I'm a manager of the enablement and training team with Data Meaning. And in this video, I'm going to talk about how to train your machine learning project for success. In this presentation, I'm going to talk about the different types of analytics, what's machine learning and why it matters now, and the machine learning and data science lifecycle, and why so many of those initiatives, the machine learning and data science initiatives fail, and how to be successful. I'm going to start to talk about the types of analytics, but first, we can see in the market a lot of experts and also software companies talking about the analytics maturity model, and that's usually presented as just a curve or just a line. And sometimes we believe we can just go forward in a straight path, but I'd like to present that in a different way. So I'm comparing the analytics maturity model with the Maslow pyramid of this motivation model. This pyramid, you probably have seen this Maslow model before, and it describes the human needs, our needs. And we can go from the basic needs, physiological needs, to the self-esteem, aesthetics, and to the transcendence. And I like this pyramid because basically we see that at each level, we depends on the previous levels. And that's how I'd like to describe the different types of analytics. So first we have the descriptive level, then we can move forward with the diagnostics, and then we move to the predictive level and then the prescriptive. But what are they? What do they actually mean? So let us take a look at these four different levels and what they mean. And I'd like to describe them or associate them with the main questions. At the first level, the descriptive level, we're just collecting data and talking about and answer questions about what happened. Uh, where are my clients? Where they are? How much did I sell? Or how many items I have in my inventory? And then I can move forward with more interesting questions about why did it happen? So why did I have an increase in sales? Or why did I have some issues with the profitability? And we basically use the same data with more interesting analysis and visualizations. And I'd say most of the companies or teams, departments are at this level. And then as we start talking about data science and machine learning, we just want to move to the next level because so far with those first two, we're just looking at the mirror. We're looking at the past, what happened there and why it happened. And then we want to take a look at the future to see what will happen. We want to have a glimpse of the future. We want to see what will happen and get ready for that. And then at the top of this pyramid, we have the prescriptive. How can I make it happen? How can I optimize my outcomes? And I put that as a pyramid because at each level, we depend on the previous. So I will only be able to do forecasts, to do predictions when I have this solid base of my pyramid with all the data and other analysis to understand what's going on. So that being said, let us focus on the top of the pyramid, those two levels with the predictive and prescriptive. And we're going to talk about machine learning and why it matters. First, let us start with the definitions. What is machine learning? And again, in the market, you can see a lot of different definitions, and I'd say most of them are fine. They're very useful, but for this presentation, I'm going to focus on this one. So machine learning is the use of computer systems, that's why machine, and we're going to use those computer systems to look at the past, to identify patterns in the data set, in the data, and that can help us evaluate the present and predict the future. So it's machine learning because we can use those models, those algorithms to learn from the past, from the data that we already have to make those predictions, to identify patterns, and to make assumptions and forecasts. And then we can take a look at the different types of machine learning, and I'm going to focus on these three. And again, you can see different ways to organize, to categorize different machine learning models. And we're going to start with the supervised learning, unsupervised, and reinforced. For the supervised models, we're going to train our models. We're going to offer data from the past to predict the outcomes based on a specific outcome that we want to predict. So that's our targets. For example, we can predict the customer churn, the customers that are going to leave our company, they will stop buying, or they're going to cancel the services. And we use that, we can do that by putting this target. We look at the previous churn and we can get those patterns, and then we can take a look at our current clients, our current customers, to predict which ones are going to leave us. So there's a specific target, and that's why we call that supervised learning. Then we have the unsupervised, and those are algorithms that they're going to find patterns in the data set by itself without a specific outcome. So for example, we just have all our clients, all their buying behaviors, all those variables that can describe the client, like the location or just the demographic profile. And those algorithms, they're going to cluster, they're going to organize the clients by similarity. That's why we can cover customer segmentation or store clustering, employee segmentation, and so on. And the difference is that I'm just providing the data and I didn't choose any specific target. And then we also have the reinforced learning, and that's a different type of algorithm. I'm not going to cover much of this in this video, but those are models that can learn by the maximization of the rewards it receives. So you don't have a specific outcome. You're not just looking for patterns, but sometimes we can compare that with a game. So for example, the trading strategy, we're trying to optimize options trading, and by each one of these steps, you're going to reinforce the outcome. For example, you're maximizing the profits of all those transactions there. Again, other models like these are the driving behaviors of self-driving cars, and again, real-time pricing. But in general, and again, let us say for most of the initiatives, we're going to use the supervised and unsupervised. And for the next step is why it matters. So given those different models, we can do pattern identification. So we're going to get a better understanding of the present. We can understand our clients. We can create some very useful segmentations, for example, and then we can take a look at the future with predictions. We can create more robust multi-dimension solutions. For example, in many cases, we take a look at our clients and we just organize them by their revenue. We can create those ABC curves, but in this case, we're going to take a look at many different variables at a time. So it gives us a more solid solution, and then we can we can create our, for example, campaigns or our actions in general based in more details. We can customize our approach. Then we can also have the automation. For example, you can use the credit score to make decisions about if you're going to provide credit for your client. Of course, you can have your group of analysts with a lot of experience in making those decisions, but we can also automate a lot of that work. In many cases, we can automate the the limits of this decision. For example, if you're going to approve the credit, yeah, you can automate the end of the spectrum, and if you're going to deny it, it's also easier to automate the end of that spectrum. And then in the middle, you might have a gray area, and then you can still use the manual analysis of all those decisions, but you're still automating a lot of that work. You're gonna get more accuracy with all this data with the multi-dimension solution, taking a look at the future, getting the patterns. You're going to be better and faster, and you can get more accuracy in those decisions. And we can also go from insights to action. So again, as you can get all this data, you're getting automation, you're better at making decisions, then you can get the data, get the insights, and make the decisions and get the action. So, so far we can see how important and what type of things we can solve with data science and machine learning. But now we're going to get a better understanding of the machine learning lifecycle. So what a project like this look like. So we can see in the cycle all the different steps, all the different areas of those projects. We start with the objectives, of course, and then we gather all the data that we need. Then we need to do the data prep. We need to explore the data in more details, and then we move to the model itself. We need to interpret the results, and we need to make some along the time as we're using those models. We need to put some. We need to make some maintenance there. When we compare this to a descriptive or a diagnostic model, we're going to find some differences here. And as we discuss why so many of those machine learning projects fail, and the statistics show us that 87% of those initiatives fail. You can find different articles describing and putting those numbers for analysis, and you can get different results, but this one is the one that gets most of our attention. And why is that? Why so many of them fail? And we have issues with all these steps here, starting with the objectives. So for example, a lot of different projects fail because we don't get the proper issue to cover and solve with the machine learning models. Many companies started initiatives like this just for the sake of exploring machine learning, and that's why some of them fail. When we move to the next step, a lot of them fail because we don't have enough data, or we have so many issues with data quality. So data quality is really critical here in those machine learning models. And then when we're doing the data preparation, here it's going to be different from just the regular descriptive analytics. And we can see those differences with the data preparation and data exploration, because we're going to offer this data to the machine so we can get the patterns as we saw in the definition of machine learning. We're going to provide the data there, so it needs to be ready. Again, data quality is critical. We're going to provide the data, and when we're building reports or dashboards, sometimes we're missing some data or we have outliers, and they're fine because you can see the data there directly, and then you can just think about it and remove those lines, those results from the data. But as you're using the model and the model is learning from the data, then you need to take care of all those things. And when we look at this diagram, we need to think about the Pareto rule, and just 20% of the time, we're talking about data science and machine learning, but most of the time we're just doing the data preparation and the data investigation, data exploration. So it takes us 80% of the time to get to the point where we're going to do the predictive modeling itself. And then as we do this model, we need to interpret the results. And that's another reason why so many of those initiatives fail, because we have different models, different ways to tackle the problem. But one of my recommendations is that we start those initiatives with something that is easier to understand. So for example, if we start with the decision tree, you can just put that on a flow to see the decisions that the machine made, and then you can just get your experience to evaluate that, to judge the paths that the algorithm took. But if you're using something more complex like the neural network, then it's going to be much more complex to understand those decisions behind all the math. And then later, uh, it's important to highlight here that it's machine learning, the machine learning, but this whole process is guided by us. We are providing the data. We need to understand what's going on behind the scenes, the decisions, the assumptions that the model made. So it's guided by us. So machine learning learns from our data. And then it requires, as a machine, it's going to require maintenance over time. We're going to put a model in place. For example, we're going to predict the customer churn, or if we're going to sell new products or services. And over time, even the market change, the products change. So imagine how we made the decision on how to buy a mobile phone in the past, a few years ago. That would be completely different. We would just call our friends, call our family, or use that to work. But over time, we just move to use internet. We need internet. We need to use apps. So the whole thing changed. If you have if you had built your model in the past, you will need to provide more variables, new data, so the model can learn again, can learn those behaviors to make good predictions. So it requires maintenance. To summarize a lot of those comments about the different steps, let us see why many of those initiatives fail and how to be successful. So we had a lot of different issues in all the steps of the life cycle, and they start with wrong targets. You don't get the proper goals before you start. A lot of them fail as well because we just start with something that is too big. You will need a lot of data, a lot of people, and a lot of different resources to make it done. And that this one it's really dangerous. It's a very dangerous path. Another thing, it's tempting because you're getting a lot of data and a lot of different insights from the data exploration, and you can just keep increasing the scope. You want to tackle so many different aspects of your business, and that's another very dangerous path. Another issue is that sometimes we don't have enough data. We don't have all the data that we need, for example, to predict the customer behavior, or we have so many data quality issues. So for those two, we can handle by controlling the scope and also, let us say, the expectations. Another difficult step or another difficult thing that can happen is that you have unexplainable results. And over time, you have degrading machine learning models because the behaviors are changing, the market is changing, and we need to take care of the maintenance. So a few guidelines on how to be careful with those traps. First, we need to align our initiatives with the company goals. It might be a little bit obvious, but it's really important. So we need to align those initiatives with the company goals, with the team goals, and challenges. I'd say especially for the first machine learning projects or initiatives, we need to keep it simple. So let us limit the challenge that we're going to solve and try to get your first insights and your first models as soon as possible, and then you can just iterate and get better at those results and to get and to tackle other challenges. So define your deliverables very well and iterate upon those results. For the data, we need to assess the data availability as soon as possible during that project, and also the data quality. And then if you have issues, you can just adjust your goals and the scope of the project. So maybe you don't have all the data for all the markets, but you can build the first model for just a segment of your clients or the market. Uh, with those different models, I'd say we should focus on the models that we can understand the results, the one that are more explainable, even if we need to sacrifice a little bit of the accuracy, but it will give you more a more understandable, and you'll be able to trust the model much more. And then are you more comfortable with machine learning? You can just use something more advanced, even if you cannot understand all the details of the decision that the machine made. And from the beginning or during the project, maybe you already started, make plans to revisit those models to see if they're degrading, and to have another phase to iterate, provide more data, and then get your results. So in the beginning, I mentioned that a lot of companies, they're still at the descriptive or the diagnostic levels. And for that, just a final thought that if you want something new, you have to stop doing something old. So you need to get your first steps in the direction of the machine learning and data science, because with that you can just make the predictions, forecasts, and make better decisions. So that was the video. Thank you for watching. If you have any questions, you can reach us at info@datameaning.com. You can also book a discovery call so we can discuss your analytics maturity level and how to get to your next step. And please follow us in YouTube and also LinkedIn. And again, thank you for watching.